Hello world, microcats! In this form, we will try to assemble a push-pull converter. Let's program the controller's timers to work synchronously with the FS shift therapy cheating dead time. And let's check if a cold plasma can light a match, a paper, and a light bulb. This is the first sheet showing the low voltage control circuits. A push-pull stage is located on the electrical board, consisting of two transistors, a driver and a 5V converter. Terminal blocks for convenience. Mounting fast. The STM32 microcontroller controls the operation of the entire electrical board, powered either from an external source or from two 3.7 volt lithium batteries. High voltage circuits are drawn on the second sheet. TR1 and TR2 are transformers whose task is to receive a high voltage. TR1 is a voltage boost transformer. It produces a small voltage of about 100 volts and shakes TR2. TR2 is an output transformer with a large number of turns on the secondary winding. Its output has a very high alternating voltage. This voltage can be straightened and multiplied. For this, a diode capacitor multiplier is used. From its output, we obtain a huge constant voltage and supply it to a arrestor. Let's move on to programming. We include the required header file. We switch from the internal clock source to the external crystal resonator. We configure the PLL module. Configuring internal bus prescalers. We allow the peripherals to be clocked. By the way, STM controllers are quite resistant to spark interference, unlike my USB port. Here is what happened on the prototype, even without a volt boosting transformer. We configure the port C13 LED and opto relay as push-pull. Each transistor will have its own PWM channel and they have different timers. Alternative push-pull mode of operation. Setting up a timer. Knowing the frequency of the timer bus and the divider for this bus, we get the clock frequency of the timer. We calculate the internal timer divisor. We get the duration of a single tick. We set the value of a reboot register, cumulative account. The divisor of a dead time generator is 1. We do not use the event repetition counter. We initialize the timers in the same way. We calculate the duration of a high state. Configuring the PWM channel. A complementary PWM channel is not used. its output is disabled. We initialize the timers in the same way. It is these settings that allow you to light a match and paper. We synchronize the timers, namely we configure them as a slave and a master. Allow timer 3 to generate an internal signal when it is on. We transfer timer 3 to master mode. We set timer 4 to the input trigger by which it will switch, and this is the internal signal of timer 3. We transfer timer 4 to slave mode. We adjust the dead time, or the shift between the edges of the signals to the transistors. Using suboptimal settings you can achieve generation, but with the strength of a spark discharge it will not be enough to set the paper on fire. We start synchronized timers. Slave first, then master. We go into an endless loop to check what happened. Here is what happened on the table. On the left is a familiar assembly from which we will take power. This is a board controller with transistors. Here is the board itself with Mosfets and a driver for them. Voltage boost transformer, main transformer, multiplier 5 stages, homemade arrestor. Well, it works. It can be seen that the arc is powerful, but the paper does not burn. The discharge immediately burns through it. It's the same with another piece of paper. He sets fire to the match. Instead of bolts, we install self-tapping screws. We say that energy-saving lamps react to high voltage. Let's check it out. It can be seen that the lamp is lit, and only through one of its contacts. Paper can be easily set on fire if folded in several layers. Let's try to light a spark, a lamp and a match at the same time. By the way, the accumulators had already set down, so we had to connect an external source. Its voltage is set at 8.4 volts as in a fully charged lithium battery. Fast. Let's move the plates. It turned out the match was lit. Now let's check the distance of 20 millimeters. As you can see, there is a breakdown of air. And now we control the plasma with a screwdriver. That's all. See you in the next video. Subscribe, Microcat.